this is the best solution that I could come up with for the three-sum or finding triplets that sum to 0 coding challenge. So basically, this is building on this is like the second solution that I was able to come up with for this. The first was using a hash map to make sure that there weren't any duplicate subarrays. Just to go over the problem, once again, you're given an array of unsorted numbers, and we want to find all the unique triplets or unique subarrays of length 3 where those numbers add up to 0. So for example, given this input here, it's unsorted, we would want to return an array of these arrays. So -3, 1, 2, and see how they're all unique. There's no duplicate subarrays within that. So this new solution basically is going to use the two-pointer technique at each iteration of, like, we're going to loop through well, first we need to sort the array so we can use the two-pointer technique. So once the array is sorted, we're going to iterate over the numbers within our array. And then given that current number that we're on, we basically want to use the two-pointer technique so that we find two numbers within the subarray after our current number that equal to our current number times -1. So basically, like, if our current number is 3, we want to find two numbers that add up to -3. So yeah, and we also want to skip duplicates when we increment I. So, or I is like the current index that we're at, iterating over the current array. And we also want to skip duplicates when we increment or decrement our right and left pointer. So, yeah, so here, sorting the array. I don't know what Go's doing behind the scenes with its sorting integers algorithm, but anyway, so we're iterating over the length of the array, and the reason that we want to stop before the length of the array -2 is that, for example, if we're iterating through this one that we're given, if we continue to this 1 right here, we don't have any room for our left and right pointers. So we want to stop at -1. So our left and right pointer would be 1 and -2. So back to the code. So yeah, that's why we stop at while we continue iterating while I is less than the length of the array -2. So to skip duplicates of I, we essentially just check if we are greater than 0, so we're able to look at the previous element of the array, and we take the current element of the array, and if it's equal to the previous one, then we just continue to the next number. So if it's not, if it's a new one, then we want to make our left and right pointers for the subarray that we're using the two-pointer technique on. And so the left side would be I plus 1, so one further than our current index, and then essentially the end of the array for the right side pointer. So we want to stop our two-pointer technique once the left side is greater than or equal to the right side. So basically, we don't want to do anything if they're equal to each other. So yeah, basically we want to get the current sum. So we're looking for a sum of 0. So we take the elements at I, our left pointer and our right pointer, get the sum, and then we're using Go's switch case syntax here. So if it's 0, then we have actually found a triplet, and we want to append it to our answer. So we do so. And then we just want to increment our left side pointer. If the sum is less than 0, since our array is sorted, then we know that we want to add to our current sum. So basically, we increment the left side pointer. And then if it's greater than 0, then we want to decrement the right side pointer because that would subtract from our sum since the array is sorted. And then we also need to make sure that we're skipping duplicates when we're incrementing our left and right side pointers using the 2-pointer technique. So when do we do that? So we basically don't want to check for duplicates if the left side pointer is 1, if its index is 1, because that means that the previous one to it would be I, essentially, and we haven't had any previous left side pointers. So if the left side pointer was 2, and that current element at the left side pointer and its previous one are different, then we just want to stop checking for duplicates. But if they are the same, then we want to increment the left side pointer, and then we would just keep checking essentially until this condition was met, or until it wasn't a duplicate. And we essentially want to do the same with the right side, but it's a little bit different, the condition. So we want to make sure that if it is the last element of the array at the right side pointer currently, we don't want to check for duplicates. But if it is less than that, so like if the length of our array is 7 and if the right side pointer is 5, then we want to check for duplicates. So we do so here. If they are the same, a duplicate, then we want to decrement our right side pointer once more. So once we've continued to iterate through and use our 2-pointer finding triplets, then we just return the answer. Got a test for the previous solution and the current one. This code will be available in the description. Let me know if there's a better solution or other improvements to make with this. Just trying to improve. So yeah, thanks, and on to the next one.